So our next video deals with when you have several different types of compounds grouped together and you have to determine how to name them, which it will be important for you to be able to differentiate different parts of the name that you will need. You need to be able to make decisions about whether or not you're crisscrossing, whether or not you're using prefixes, whether or not you're using Roman numerals. So I want to just start by talking about how we would actually sort these. There's a whole bunch of compounds up here for you to look at. And I gave you some boxes in your notes. You don't have to write down every single one that's up here, but it's important to kind of think about how we determine if something is just regular old binary naming, binary ionic naming, whether or not it's ternary, whether or not it's stock, it's going to have Roman numerals, or whether it'll have prefixes like the two nonmetals. So the first thing that I actually look at is I'm kind of glancing up at these and saying, okay, how many capital letters do we have? That's a question I usually ask myself, because I can very quickly see, oh, look at this guy. That has something from table E, something from table E, something from table E. And again, you don't have to write every single one of these down, but it's important to be able to kind of check these out, see if you, sorry, got someone at the door, they left. So it's very important that you're able to check these out and kind of identify, like, hey, do we think we have something from table E? That's a nice first check. So you can kind of select a few of these that you're going to write down as examples. So now looking at the board, oops, I missed one. Everything that has more than two elements in it, or more than two capital letters, I have taken out and put in that ternary box. Now I know when I'm naming them that I follow the ternary naming rules. Next, I'm going to say, okay, I've got ones that have two nonmetals, or stock system, or binary. So it's kind of up to you how you want to approach this. In order for something to have two nonmetals in it, you have to have two elements that are the same side of the periodic table. So the first thing I'm going to do is I'm going to look, for example, at Fe2O3. So put one finger on the periodic table on iron, put another finger on the periodic table on oxygen. You will notice your fingers are on opposite sides of the periodic table. What this tells me is that this does not go in the two nonmetal category. It either has to go in the binary category or it has to go in the stock system category. So then what I want to do is go to the periodic table and take a look at iron. And I will notice iron has multiple positive charges. So what that tells me is this will have a Roman numeral in its name. So next one I'll look at is CO2. Put a finger on C, put a finger on O. Oh, they're same side of the staircase. So that's going to go over here to our two nonmetal category. CaS, for example. Put a finger on Ca, finger on S. Those are on opposite sides of the staircase. And you'll notice calcium only has one possible oxidation state, so that automatically goes in binary. It does not need any Roman numerals. So take a minute, select a few more of these, put them in the box where you think they belong. You can pause the video for a minute. What's very important is being able especially to identify which ones are going to be stock system and making sure you know when you're going to use parentheses. So pause the video for a minute, I'll place these, and then you can check your answers. Now, there's one little tricky example up here, and that's one more. The example of H2S is a little bit tricky. We actually pretend that H is on the other side of the table. We pretend it's right next to helium. I'll talk a little bit more about this in class. It's actually because hydrogen actually is a nonmetal, even though it's placed on that metal side of the periodic table. So that's kind of an important weird exception to make sure that you know. So what you need to be able to do is take a look, and if you jump to page 28, there's a bunch of compounds here. And you need to be able to ask yourself some questions, and I kind of put together a little flow chart that illustrates my thought process that you can choose to use on this if you want. So you should have a handout of that that's not in your packet, but that's separate. So the first thing I do when I look at a formula is I say, okay, what have I got here? How many capital letters do I have? So oops, just a second. All right, I'll show you that graphic in just a second. So I look at how many capital letters do I have? And because I can see that I have 2 capital letters, I can then make a pretty good distinction that I know I'm not going to be using table E automatically. So I'm following this arrow right here, and I'm saying, okay, are my elements on the same side of the staircase? That's my next question. Let's put a finger on NA and a finger on S. Making my life easier. And with one finger on NA and one finger on S, I can see that these are not on the same side of the staircase. So no. Then I have to ask myself, does my metal have multiple oxidation states? Sodium only has one possible oxidation state. So I say, okay, nope. Binary ionic, no Roman numerals there. So I've also included on that sheet, if you go down a little bit further, it does give the basic steps for each of these, but that just covers what we already covered in class before. So you should be able to follow this flow chart to kind of get the hang of some of the separation of these compounds by their type. So we can name this guy simply sodium sulfide. So I know that I'm going to be changing my ending to I because it's something from the periodic table. I have no prefixes, no Roman numerals. So next I look at PCl5. So how many capital letters do I have? So in PCl5, I have 2 capital letters. So I'm going to go this way again. Are those elements on the same side of the staircase? In this case, yes, they are, which means I will have a prefix in my name. So then again, you're just going to follow that prefix naming system that we did before in order to indicate how many of each element we have. So this is going to be, triphosphorus monochloride. So in our next example, AlPO4, now we have more than 2 capital letters, which is an automatic indication to us that we're doing ternary ionic naming. So we're going to be using reference table E. So this is aluminum phosphate. So in our next example, we got FeBr3. So we have 2 capital letters. So we're going to go this way. Are they on the same side of the staircase? No, they are not. Do we have multiple oxidation states? Our metal does have multiple oxidation states. So since our metal has multiple oxidation states, we know we use the stock system, which is when we use a Roman numeral. So this is going to be iron. We have to figure out what that Roman numeral is. So we've got 1 iron, 3 bromines with it. Each bromine's -1. So this is iron 3 bromide. So you can take a moment, pause the video, work through a few more of these, and then I'll put your answers up for you. So the answers to that column, I'll leave that there for just a moment, and then scroll it down for you. So it's important to be able to understand why number 9 needs a Roman numeral, why number 10 has prefixes in it. It's also important to understand why one like number 13 does not have prefixes in it. So it's important to be able to make those distinctions. We also need to be able to look at a bunch of names and turn them into formulas. So what's important here is going to be deciding whether or not we actually are going to have to go ahead and worry about doing crisscross, or if the name itself tells us, you know, how many of each one we have. So this can actually be quite a bit easier. So when I'm looking at this, what stands out to me very frequently, students say, oh, I got Roman numerals. Let's go and categorize those right away. Those are very, very straightforward. Anytime I have a Roman numeral, I can pull that right out of there. So I'll put all those guys down there. I'll scroll that down in a minute so you can take a better look at it. I've got them all kind of piled up. So it's very quick and easy to see, okay, these names have Roman numerals in them. Keep in mind, the first three types of naming up here, when you go to write these into a formula, they will all involve crisscross. The prefix naming does not involve crisscross. So another thing that a lot of students like to kind of, pull out of here really quickly is any that they see prefixes in, like carbon monoxide, hexasulfide, tetrabromide. So any of these that you're, oops, I've got that guy right there. Any of these that you're seeing those prefixes in are very easy to pull down here and say, okay, we're not doing any crisscrossing with those. And you got to determine if you're going to use table E or not. So you really have to look here, somewhat at the ending of the name, and just make sure if you recognize anything from table E that you pull that down. So calcium nitrate has something from table E. Calcium sulfide does not. So that's regular old sulfur that goes in here. Phosphate is table E. Hydroxide. Here, I'll pull some of these down, then I can move them around a little bit. Barium chloride, zinc chloride, those are just elements. Ammonium is from table E. Sodium bromide is pretty straightforward. So when we're looking at each of these, we just want to make sure that we're properly using table E when we need to. But again, all of these include doing crisscross. So that does make this a little bit more straightforward. We're going to crisscross with the first three types, but if we have prefixes, we don't need to. So what I kind of like to think about, make sure that you're looking for Roman numerals. Check out anything from table E. And remember, prefixes don't use crisscross, whereas all of our other formula writing does. So if we're going to jump back to page 28, you're looking at ammonium nitrate. So what stands out to me is both of these are from reference table E. So you're going to flip to your reference table E and get your formula for each one. Because this is ternary naming, you do crisscross. So ammonium is NH4 with a +1 charge. Nitrate is NO3 with a -1 charge. When you crisscross them, you simply get NH4, NO3. Calcium oxide. So I don't see any Roman numerals there. I don't see any prefixes there. So calcium oxide, I can double check if they're on the same side of the staircase. Calcium's on one side, oxygen's on the other, so there's crisscross involved here. So calcium is +2, oxygen is -2. Those end up canceling out, and we get CaO. Next one, nitrogen trioxide, you'll notice, there's a prefix there. So that's really straightforward. We have 1 nitrogen, 3 oxygens. No crisscross because of that prefix. Rubidium phosphide. So neither of those things are from table E. If we check them on the periodic table, they are opposite sides of the staircase. We have no prefixes, no Roman numerals. So Rb has a charge of +1. Phosphorus is -3. This is simply Rb3. P. That 8 ending clues me into this being something from table E. So magnesium. And then I go to table E, nitrate. And it's important to remember in this one, you got to remember all the stuff we learned before. This one will get parentheses. I wanted to get down to number 6 because there is a Roman numeral here. So as you're noticing, unless you have the same side of the staircase, and you have a prefix in your name, you are going to be using crisscross on most of these. So nickel, because they're telling us Roman numeral 3, remember, has a +3 charge. Then we look up the charge for sulfur, Ni2, S3. So it's important to be able to make sure that you can go back through and really, decipher when you're going to be crisscrossing, when you're not. Whenever you have things that are on the same side of the staircase that have prefixes in the name, you will not be crisscrossing. So take a minute, pause, and work through these, and I'll pop the answers up in just a moment. So you can check your answers to the first few. And I'll scroll it down. And I'll scroll it the rest of the way. And we'll do some more practice with these in class tomorrow to make sure that you're comfortable with worrying about naming when you have mixed examples.